Southeast Conference. She lives and works in Thorn Bay, Prince of Wales, where I believe she is right now. Karen coordinates the Alaska Wind Energy Development Task Force Group, and organizes the biannual Alaska Wind Energy Conference. She has a master's degree in rural development from the University of Alaska Fairbanks and an undergraduate degree in agronomy from the Washington State University. Karen is a returned Peace Corps volunteer who spent 3 years as an ag extensionist working in rural Ecuador. So, Karen, welcome, and assuming you're still there, because I can't see any longer.
Yep, I'm still here. Thanks, Jim. Can you guys just really quickly let me know who's there in the room so I know who might be asking questions?
Absolutely. We'll start with Jomo.
Jomo Stewart, Fairbanks Economic Development.
Roger Bergerath, Miner.
Michelle Onsor, FEDC.
Mike Crox, I'm with a group called Smoke Busters.
Mike, was that Mike?
Yes.
And Lisa Barra for the Northern Alaska Environmental Center.
Brittany Hartman, Associated General Contractors of Alaska.
Bill Clemenson, taxpayer. Carl Hahnemann, Tower Hill Mines. Clark Milne with Dow Engineering Firm. Carl Wilson, CNR Pipe and Steel.
And Jim Dodson. So, Karen, welcome, and the floor is yours.
Thank you so much. That's quite a room full there, and I appreciate everyone getting out of bed early and coming in this morning. I talked with Jomo, and he asked if I would just give an overview about the Alaska Wood Energy Development Task Group. And I'll just say right now, if you have any questions as I'm speaking, just feel free to jump in and ask. Sometimes it's better to answer the questions in context, okay? So it's no big deal. All right, just a little bit of an overview. I'm driving the boat here, so let's see if I can make this go. I've lost my little cue thing. There we go. So who are we? The Alaska Wood, you can read this as well, but just a quick little run through. The Alaska Wood Energy Development Task Group is 11 years old this year, and we're the brainchild of Dan Parent, who works today with U.S. Forest Service State and Private Forestry. At the time, he was working for Juneau Economic Development, JEDC, in Juneau, and the idea was that we were having a real hard time getting wood energy projects off the ground, and so it was thought that perhaps we might develop a process for screening and getting projects, lined up so that we knew what communities were interested in heating with wood. So a lot of folks ask whether or not we do electrical projects as well. We have done those, but mostly we focus on wood heating. Since the Alaska Housing Authority handles residential buildings, we handle commercial buildings, anything that's not residential. So municipal, tribal, federal, institutional, commercial for wood heating. We have a really big group of stakeholders that work on promoting these projects and vetting them to make sure that they are good projects to move forward. And there's the whole laundry list right there. So you can just kind of take a look at that. But it's a pretty diverse group of federal agencies, state agencies, and nonprofit organizations across Alaska. And what do we do? Well, we are hosted under the Alaska Energy Authority's direction, and the Alaska Energy Authority's mission is to reduce the cost of energy in Alaska. So we only work with projects that really make sense. And why biomass? We have found that in a lot of cases in Alaska, biomass pencils out better than heating with a fossil fuel. The money that is spent on fuel stays in the community, and we found that we create local jobs and local businesses. This was not our original intention when we started this program. Our thought was we would just help cities, schools, tribes, you know, governmental entities save money on heating fuel, and that is simply the criteria that we look at when we are evaluating projects. But we have found wherever we have successful projects, it also comes with the creation of local jobs and local businesses, firewood cutting businesses specifically, but also the people that operate the systems, people that build the systems, and so forth. And I've got down here at the bottom, Galena is a big biomass project. You know, they've got the boarding school out there, and they converted that all to wood heat. They harvest their own land with their own employees for the fuel, and they've got a huge annual payroll. And all of that money that they spend on heat stays in the community, and that's money that goes to the utilities, that goes to the grocery store, that goes to, you know, paying rent or whatever it is that you need to do, as opposed to leaving with with the fossil fuels. So, and how does the process work? It's super simple. I did ask Jomo to print off a copy of the application, but here's just a little JPEG photo of it. If you're interested, you can send me a paper copy. So it's a 3-page statement of interest. It's the first page is, who are you? What's your name? Are you the City of Thorn Bay, the City of Fairbanks? Are you the University of Alaska? Are you Klawakenia Native Corporation? So there's all kinds of names that can get put in there. Who is the main contact? What is the mailing address in what city? And so forth. The second page is simply, what are you trying to heat? What building do you want to heat with wood? And if you've got a number of buildings, then you just put in an extra page for every building, and that just gives us a thumbnail idea of what the existing infrastructure is. So we evaluate these statements of interest, and our criteria is twofold. If you look at the letter, basically we are looking at displacing X number of gallons of fossil fuel, or if you are paying a lot for fossil fuel or energy, then we are looking at helping you reduce that cost. So most projects do pencil out. Sometimes they're too small. If it's a very small building, it might just be best suited for putting in a wood stove, like a regular wood stove, as opposed to putting in a big heat system. But if we accept you, we hire an engineer. We work with FEDCO for this. Michelle and Jim are the folks that help us run this request for proposals, and they administer the hiring and oversight of the engineer that we end up hiring to do a pre-feasibility study. One of the things that we require at the end of the study is a teleconference with the engineer and the community to review the study and discuss next steps. We just added that a couple years ago. And the reason why is we were finding people would apply for one of these studies, we would go and do it, and then 2 years later they would apply again, because there would have been a change in administration, and the new administrator didn't know that we had already done one. So now we make sure that they read the darn thing. And we talk about, is this a good project? Why is it a good project? And we talk about the cost benefits for that. Some communities have the capacity to move forward with that. Sometimes it takes them a little while to sit on that. So this next slide is just a picture of all the places in Alaska where we have done pre-feasibility studies. We've been fairly comprehensive around the state in studies, although we'd like to have a few more out in the Western Alaska area. Is there a question? Okay.
Just so you know, Karen,
Anyway,
I did print out the information that you had sent me, and so everyone has it. And
Yep.
thank you for this map, because actually you all have done a lot of these pre-feasibility studies.
Well, we've been around for 11 years, right? And so that has given us a lot of time to do a lot of studies. And one dot does not represent necessarily one study. One dot just represents a community where studies have happened. So, several of these dots, there's multiple studies in those communities. And so just taking a look at where we've had projects, these are all the places that have grown to projects. So like I said, we'll do this study. Not all studies pencil out in the positive, and not all communities are ready to move forward with design, engineering, and construction of a project. So we have found it takes about 5 years for us, after a study happens, for the project to kind of move forward. And we'll go back and we'll revisit with folks. We'll say, hey, we did a study a couple years ago. You guys looked at your water treatment plant. Are you still interested in moving forward with that, or how's it going? Maybe you've done a different way, So just a little bit of a history of Alaska. Yeah.
Mind pulling up the last
Yes?
slide that showed all the projects you have studied?
Yeah. Oh, this one here, all the locations where we've done projects. Yes. Is that the one
Okay.
you want?
Yeah, thank you. Yeah, thanks.
Yep, no problem. And that might be just a little bit behind the times too, but I think it's pretty good. So these are, like I say, these are all the projects that have been constructed and are in operation. I just wanted to give you a little bit of a overview of biomass projects in the state of Alaska. First major project was in Craig, which was installed in 2007. We started that project in 2003. No surprise down here, because I worked with them, and this was my master's thesis for my degree at the University of Alaska Fairbanks. It predates the Alaska Wood Energy Development Task Group. And SEALASKA was right after that, 2008, with the first pellet system installed in the state of Alaska. So one of the places that we've had a great amount of success has been with schools, and part of that is just how schools get funded and how much they end up having to pay for energy. And we have had fantastic success with school projects across the state. And in fact, we've done pre-feasibility studies for the Fairbanks North Star Borough School District. 4 of them: Weller, Salcha, Two Rivers, and Pearl Creek. Whoops, sorry. None of those projects are moving forward at this time. We selected those 4 schools because they were outside of the natural gas build-out project that was proposed for Fairbanks. And I have to say, I don't know exactly where that is in moving forward in Fairbanks, but we figured those schools would never get hooked up to that. And so they were all really good projects. 2 of them were excellent projects. 2 of them were fair to Midland projects. But all 4 of those schools penciled out.
Which were the
So just a little
excellent
bit
ones?
of what's that?
Which 2 were the excellent ones, if you can?
Oh gosh. Let's see.
No, it's okay.
No, I'm just thinking, I think Pearl Creek and Two Rivers were the 2 better ones. I'll have to go back and check though. I've got all of those studies. Who's asking that?
That was Jomo.
Oh, Jomo, okay. Yeah. Yeah, I mean, we can have a conversation later on, what some of the challenges are with moving that project forward. But I think you are well aware of some of the challenges with biomass projects in Fairbanks in general.
Another question with
So
that.
I always have to.
Actually, Karen, 1 second. We have a question from Clark Milne.
Yeah,
Okay.
Specifically on that project list, was that actually a timeline order? My memory is that Token Delta indeed were among the very first ones, and they were such good showcases that it led to these others? Is that actually in chronological order to a degree?
It's not perfect because Craig is out of order there, but it is mostly in order. Yep, and you can see the two bottom ones, Husli and HYDABURG, are in construction.
Thank you.
Yep. We just do a little review of what biomass is. I think we all have a pretty good understanding of it, but when the word biomass gets used, some folks think of a lot of different things, and it is true that solid waste and corn husks and a bunch of different things can get counted, but here in Alaska, we just really are referring most of the time to wood. So just a little bit about the technology that we're using here in Alaska. We've got these cordwood boilers that have been installed across the state. There's a picture of one here. I call that a naked boiler because it doesn't have its little building built around it. And then the building down below, you can see it's just an easily filled cordwood boiler. And this is kind of a cutaway of what it looks like on the inside. That entire boiler space is filled with water, and you can see that the exhaust tubes run back and forth through that water, which is how they're transferring heat. And these end up being virtually smokeless when they're installed. And just a little disclaimer here, not all biomass technology is equal, and we've got some, and I'm sure you in Fairbanks know this, some examples of outdoor wood boilers that don't work well, right? They can work better than average if they're operated properly, but they tend to have all kinds of stuff put in them for burning, and that makes them not burn cleanly, and they're not the most efficient because they don't have as much water storage as this garn does. If you look in this, that's a huge amount of water storage in that boiler, right? And that's like a great big battery. It's called thermal storage, and we have found that the systems that are the most efficient are the ones that have a large amount of thermal storage, specifically in the water. We also have wood chip boilers. What's that?
Ms. Karen, we had a question.
Just what is the efficiency
Go ahead.
of the wood boiler?
So the
Like that
barn, the one that we are you know, mostly installing across the state, that one approaches high 80s in efficiency, which matches a fossil fuel boiler, right? The outdoor wood boilers don't come that close, and it's really difficult to put your finger on exactly what is the efficiency of any burner at any particular moment, right? There's a lot of depends-ons. So, but the garns are very high efficiency.
Mr. Hahnemann?
So we've got,
Do you have,
Yep.
do you have any specific emissions data from your successes like the Toke or the Craig boilers? Are there?
so that's a good question, and this is actually a question that comes up quite often, how the emissions work. Public buildings have to test their emissions and have to comply with EPA clean air standards. So, so all of the boilers that we're installing do have to comply with clean emissions. I don't have at the top of my head any of the emissions data. However, I can go ahead and find that information and send it to you if that's something that would be interesting to you.
Yeah, I think if you could circulate that, or at least, you know, and provide actual emission data would be very helpful. Not hypothetical.
All right.
Something measured from existing Alaska facilities.
I will go ahead and send.
I don't know if you know, Karen, but we do have a pretty substantial air quality challenge here in the community, and so that's part of the focus of the question.
Oh yeah, I understand completely. We've held several of the wood energy conferences there in Fairbanks, And these are things that we talk about at the conference, is issues with emissions. And you need to ask these questions when you are putting in a wood heat system. Is, how is this going to compromise my air quality? It's definitely part of the process, right? Anyway, just a really quick run through on wood chip boilers. This is what wood chips look like, and they're often either auger fed or they've got a little conveyor belt that feeds them. This is a picture here of the boiler in Galena, and you can see that most of the wood chip boilers that we have are pretty large. They're very large pieces of machinery. We've got pellet boilers as well. This is a picture of the SEALASKA pellet boiler on the bottom left. It's a Kobe out of Canada. Viessmann makes these. It's really it's the Mercedes-Benz of boilers, I think. And pellets are fairly easy to feed into the boiler. So they're no fuss, no muss, but a little bit more complicated. And up on the upper right, you can see the pellet truck delivering pellets to the SEALASKA boiler, and I think they get that filled up every couple of months. So when we talk about doing energy conversions in folks' buildings, we always take a look at energy efficiency first, right? And so when our engineers go out to do the pre-feasibility studies, they don't just say, oh yeah, it's possible to heat this building with wood. They also consider where efficiencies might be gained. Can we replace the windows? Can we insulate the building better? Because this is definitely the easiest thing to do. Energy efficiency is cheaper than renewable energy, right? So we always look at these, and we found we have got quite a few pre-feasibility studies, excuse me, that we had to go and address energy efficiency issues first. And when we do that final telephone conference, we debrief with the school or the municipality or the tribe, and we just say, look, you guys have got to fix your thermostats or whatever it is that you've got that's going on, right? And then just a few things, not all projects are created equal, right? We need to make sure that a project has a community champion. It's vital to any project success. In fact, I can take you to good projects and I can take you to mediocre projects, and the difference generally is there someone who cares and champions this project? So we go ahead and we do the energy efficiency measures first, and then we take a look at the best available boiler technology with thermal storage. We put together a business plan, a wood inventory and harvest plan, operations and maintenance plans, financial plans, and we've also found that if there's no community support, then projects won't move forward, right? That's one of the biggest stumbling blocks to making projects go, is lack of community support. And sometimes it's not that the community doesn't want it. Sometimes they're just lackadaisical. They're like, oh, well, maybe it'd be good, maybe it's not. We don't care. And so those kind of projects kind of sit on the back burner until someone steps forward and cares. And you've been asking some of these questions, if you're going to promote a project, all the energy efficiency opportunities been completed, is there a sustainable supply of biomass? We can't outstrip our forests just to feed a biomass project. Is there community support, and who is the community champion? These are critical points in moving projects forward. That photo there is a picture of the Craig boiler. So just a little bit of a walkthrough on how these projects work. We did the, excuse me, the HYDABURG preliminary assessment in 2013. This is 2019, and we are just now finishing up construction. They'll probably commission that boiler this year in November or December. So that's how long it takes from taking a look at a project and making it happen. There's a picture of the boilers being delivered to HYDABURG. And folks are always asking about money, so I don't have money for all projects, but this is a general idea of how much it costs, right? Roughly, the HYDABURG project is going to be about $700,000, with the design and engineering about $150,000. It's expensive, but even with all of that expense, it's still penciled out in the black, right? It's not a deficit project. TANANA has been one of our successes. I think they're up to 12 wood boilers in that community. And that was one of the early communities that adopted this technology. And you probably are all familiar with how that translated into a reality TV show. So people were able to capitalize on that as part of their community success, right? One of the things we have started doing is offering training on how these systems work, because we found a lot of people just really can benefit from looking at and getting hands-on training.
Karen?
Yeah.
You mentioned the number 12. You mentioned the number 12, but then it broke up for a second. You said the community has 12. What were you referencing?
I believe that the community of TANANA has 12 installed functioning wood boilers.
Oh.
They started with the water treatment plant, you know, because they were having to shut it off every winter because the pipes froze in the street. I think then they went on to City Hall and some other municipal buildings, and I think the school has got now boilers installed heating the school and other community facilities.
Okay. Thank you.
Yep. We find in northern communities, a lot of the water treatment plants or the washaterias will be the first places that boilers get installed, because that is a huge heat load. We've found different entities have different ways of measuring biomass, and here in Thorn Bay and with Southeast Island School District, they've built these little racks to put cordwood in so that they can, when someone delivers wood, they can fill up this little rack, and they can immediately see how much firewood has been delivered. This is from Galena, and we've got a huge harvester that's going out and harvesting wood. That, oh heavens. There we go. That they then run through a chipper and then store in that great big covered area. And of course, these are the community champions in Galena. Go ahead.
You know what they're doing to season their wood? Or their
in Galena?
Yeah.
Well, different places have different environmental situations. I think it's pretty dry up there in Fairbanks and Galena, so I think that they are able to deck it, but I think that they really need that covered storage for finalizing the seasoning of that wood. The Galena boiler is a chip boiler, so they need to chip all of those logs before it can get fed into the boiler. And I know that moisture has been a challenge. They've got some of their logs that they've decked that have sat there, and they don't decrease in moisture very well. I think cottonwood is one of them, but other wood species do season much better, and they're able to get those dried out. And I think what they're doing now is just blending them, right? They're blending some of the wetter wood with some of the drier wood.
Okay, so these are the community champions?
Yes. Yep. And I don't know if you recognize Devaney Plenovich there in the light blue. She's with the Alaska Energy Authority. And so she's the state champion for all these projects. So just a couple pictures of some wood boilers. And costs. The Galcana community wood-fired boilers, those are those cordwood boilers. They got a Renewable Energy Fund grant from the Alaska Energy Authority for $500,000, which is not bad. Toke wood-fired boiler, that was a huge project, and that's a very large boiler. They are putting out so much heat that they've recently put in a Skinner horizontal low steam electrical generation system that they are now offsetting a good portion of the electrical consumption at the Toke school. I didn't put a picture of that in here just because it wasn't part of this original project. But they are saving about $20,000 a month in electricity costs.
That's incredible.
That's a lot of money. In fact, if you guys are interested, Scott McManus would probably come and talk to you about that project alone. Mentasta has a small chip system. It's this little chip boiler here that you see in the picture on the left. And then on the right-hand side, you see their thermal storage. That's where they heat all that water and put it into that insulated tank. And they're heating a bunch of buildings in the community, several buildings in the community. So it's a mini district heat system, and they are in the process right now of designing another wood boiler system. They're probably going to put in the same kind of chip boiler here and heat some more buildings in their community. They're very happy with how this has worked out for them. All right, we're getting close to the end here, folks, and then we'll do question and answer. Jomo told me not to go more than half an hour. So places that work well is where they've got a community supported wood supply, right? So you've got to work in your community to promote all of these things. And as we go through these processes of promoting these wood-fired systems in various communities, we'll meet repeatedly with the community, with the tribe or the city or the school board or whoever, and make sure that the community is on board with this. This wasn't in our thinking process early on. This boiler that you see here is the Kaufman Cove boiler. And this is where we learned a very serious lesson in community support. This was a boiler that was installed, I think, about 10 years ago. And again, it was installed specifically to save money at the school. But what the community rapidly found out was the school would buy cordwood and pay people right now for that cordwood. So it started this little micro economy in the community where people would go out on the weekend, cut a couple of cords of wood and deliver that to the school. The school at the time that this boiler was installed was riding right on that margin of not having enough kids to make it worthwhile to keep the school open. In small rural communities, you have to have 10 students to keep the school open. But by providing a little bit of extra money in the economy, that made it possible for a few families to stay in the community because they were able to financially bridge that gap, and that kept the school open. And so after a few years, the community now all speaks highly favorably of these wood boilers, how it provides jobs, not only in cutting the firewood, but in feeding the boiler. And it's an important part of their community and keeping their school going. Their school enrollment is now well over 20, which is huge. We just installed a wood boiler up in Whale Pass a couple years ago. That was another school that had marginal enrollment, you know, would just be right there on the edge of not having enough kids. They have 22 kids in that one-room schoolhouse this year. It's actually a two-room schoolhouse. They've got high school and junior high on one side and the elementary school on the other side. And that is huge for that community. 2 teachers now instead of 1 in that community, and that is a town that's growing. So one of the things that we have noticed across the state, and yeah, go ahead.
We have one,
Cool.
Now we're getting where I want to be. We have one question for Mr. Carl Gulke.
Yeah, hey Karen, is
Okay.
there a plan or a procedure or a process right now to go out and replant trees for growing?
So, you know, the state's a huge state, and down here in southeast Alaska where I live, there is no reforestation or replanting program in place. The regeneration, or reprod as they call it, is so high naturally that there is no need to go out and plant. In fact, they have to go through and do commercial and pre-commercial thinning after 20 and 50 years, just because the forest does come back so thick. Every forest and every forest manager has a different program. I know they do some replanting up there in the north. I know TANANA Chiefs works with communities that have reforestation programs. So that's one of those depends on questions. But one of the things that we look at when we take a look at a biomass project is where is the fuel, the wood, going to come from, and what's the plan for making it a sustainable harvesting system. So we don't, you know, again, we're not interested in wholesale clear cutting Alaska just so that we can heat schools. We want to make sure that that heat supply is consistent in years to come. So we address that in the pre-feasibility program. We've also found that schools have added greenhouses to their mix of wood-fired boilers, and that's because they can get excess heat from that boiler that they can blow into the greenhouse and keep greenhouses going. If some of them are seasonal, so they don't operate them in the dead of winter, and others are year-round, and they are supplementing their school lunch program with these greenhouse grow operations. Toke School, again, is a fabulous example of how they've made that go. These photos here that you're seeing are from the Thorn Bay School, because that's where I live. And you can see a little picture of the greenhouse there in the background. Not only are they growing produce in greenhouses heated with wood, they are including the growing as part of the curriculum in the school so that kids learn where lettuce comes from. And this has been a huge thing in Alaska. It has been so huge that we have developed the Biomass Heated Greenhouse Handbook for Alaskan schools and community organizations. And in all honesty, anybody could use this handbook if they are looking at putting in a greenhouse with wood heat. Let's say you wanted to grow tomatoes or lettuce for your community in a commercial way. This handbook could be used for that. And this is FREE free. You can download it from the Alaska Energy Authority's website, and as well as the website that the Alaska Wood Energy Development Task Group has, which I've got here at the end of the PowerPoint for you to write down if you are interested in downloading this handbook. If you cannot download it for any reason, you can get a hold of me and I can send it to you on a thumb drive or a disk. But we developed this in collaboration with the Cold Climate Housing Research Center, and it is just intended to help walk you through any aspect of heating a greenhouse with biomass or adding a greenhouse to your existing biomass system. So I've got time for questions if you've got any questions, and I've been making notes here as people have been asking me questions about things like the emissions data and replanting and so forth. So, and my contact information is on this screen if you want to just send me an offline question, or if you want to call me and say, hey, I liked your presentation, but I'm really concerned about, you know, this, that, or the other thing. You know, what do you do with the ashes or whatever?
That's a good question.
Actually, Carl's now asking, what do you do with the ashes?
We have found that these wood burning systems are so efficient that they do not produce a lot of ash. The ash that is produced can be incorporated into an agricultural grow operation, like, you know, growing beds outside, most people just dump them or put them into the landfill. They're not toxic. They're not an environmental hazard.
Have you looked into the, what do they call it, alternative energy credits markets to support these projects?
Oh, you're just singing my song. So we have been working with entities that are trying to promote the Biomass Thermal Utilization Act, which would be credits for installing biomass heat systems, or in the United States, almost every other energy entity has energy credits associated with it: electricity, geothermal, hydro, so on and so forth. But biomass does not. There's legislation that has been proposed. They're still trying to get it promoted in the Senate to walk this forward. And if you would like, I can email you a question and answer sheet that Jomo that he can send out to the group on the BTU Act. Yes, we do not have one of those in place right now, and it would really help I guess offset the cost of constructing some of these biomass systems.
Okay, other questions? Carl?
So Karen, going back to Carl's question in regards to emissions, so does EPA then require on these commercial buildings any measuring devices on the chimneys or on the smokestacks for emissions?
I think that under a certain size, they don't require any kind of emission gathering, and then over a certain size, they do. Devaney, are you online? Do you know where that break is?
Can you hear us?
I can hear you.
The anything below 10 million BTU per hour does not require any type of emissions monitoring. Above 10 million BTU per hour does, but we do, our largest boiler in the state is the Toke Delta Galena, which are 5.5 million BTU per hour. So we're well under the requirements.
So given that you're well under that monitoring requirement, do you know, is there any actual data, emission data from operating systems?
We have a very little bit of data that was collected by Daisy Wong at University of Alaska Fairbanks. I think it was just for the Delta boiler and one of the small cordwood boilers in Gulkana. Very, very limited data.
Well, that'd be helpful to see what at least what it is.
Do you have kind of a library of these projects that if someone's interested in something, they can take a look at it and what somebody else did?
So we have fact sheets on specific projects that they're just one-pagers that we can send out that say, you know, this is the Toke project or this is the Thorn Bay project. This is when it was installed, how much it cost, who's operating, how much they're offsetting, so on and so forth. All of the pre-feasibility studies that we have done are posted on the Alaska Energy Authority website. So back to that original map that showed where we had done the studies, you could go to the Alaska Energy Authority website and see those studies. We put all of them up.
Okay.
And so if you look here under resources, that second web page, akenergyauthority.org, is the Alaska Energy Authority website. And you would have to go to biomass, and then there's a link to the Alaska Wood Energy Development Task Group and all of our studies. I don't know if last year's studies got put up there yet, but I think all the others are there. And if you can't find a study, just get a hold of me. So, like I say, sometimes the study seems to slip through the cracks for some reason.
This is Lisa, and I have a question just thinking about the source wood. It looked like, just about everything you use was cordwood or full trees and that were either chipped or pelletized. Are there any systems that use sort of like the brush? I just, all I think about is just all the brush piles so many of us burn, or that you see burn after there's, and land is cleared. And it would be great to be able to utilize that rather than just, having big brush fires. And are there any systems that do utilize that and convert that to pellets or chips or whatnot?
So when you say the word brush, you're talking about the limbs and leaves and bark that's left over after the tree gets harvested, or are you talking about a specific type of shrubbery?
No, I guess, I'm thinking more about the limbs that are removed, but also I think shrubbery, like if you're in areas where there's willows and alders and smaller woody plants.
Say 3-inch diameter and less.
Sure.
Yeah, so most of the, so obviously cordwood boilers would have a hard time, you can have a hard time picking that stuff up and stuffing it into the cordwood boilers. If you could get it in there, it probably would burn, but the cordwood really needs those chunks of wood put into those. You can chip that material, so they call that whole tree chipping. They'll run everything top to bottom, leaves, twigs. The problem with that is there's not very many boilers that have been designed that can handle in their auger system that inconsistent size of material. We're constantly looking at what other people are designing, and there is one that's installed down in Oregon that we're kind of keeping our eyeball on to see whether or not we can utilize that. But most of the boilers that are installed in the state of Alaska right now that are chip boilers require a relatively consistent chip size and quality. The pellets, there's only one pellet manufacturer in the state of Alaska, and that's Superior Pellet, and I'm pretty sure they do not utilize any of that material in their pelletizing process. However, they can burn that material in their dryer that they are using to dry the material for making pellets. How much of that actually gets brought over to Superior, I don't know. In the United States, in the lower 48, where there's a lot of pellets made, most pellet manufacturers do not use that material. I'm actually only familiar with one pellet manufacturer in Show Low, Arizona, that makes what we call a dirty chip, and that's where they use everything, guts, feathers, and all. So it is a hard nut to crack, because we are leaving a lot of material behind that in your area is flammable, Some places they do chip it and spray it back onto the landscape and it composts and becomes part of the soil again, but that's not common.
Carl?
So
can you tell us,
the answer is we would like to use it.
Yeah, thank you.
can you tell us where SEALASKA gets their pellets?
Today, their pellets are brought out of Canada. The pellets from SEALASKA are distributed by a man named Al Roscom. He lives in Wasilla. He's got a pellet delivery system. He is buying his pellets from Pinnacle Pellets in Canada. They've got a plant in Burns Lake and another one in Smithers. They load the pellets into containers. They drive them to Prince Rupert. They put them on the Alaska Ferry, and they are ferried up to Juneau. That's not the most efficient way of getting pellets, and we are constantly looking at ways to make that a more streamlined process. This summer, when the ferries didn't run, that put a damper or a glitch in the pellet delivery system, and often the Alaska Ferry gets shut down in the wintertime, and then the pellets have to get sent all the way down to Bellingham or Seattle and then get shipped back up to Juneau. So it's a challenge.
Other questions?
Karen, this is Michelle. If you would just maybe talk a little bit more about the pellet predicament that you guys are facing down there, because I don't think our audience really knows about how you guys are struggling.
Yeah, and I wrote this last year, a white paper that's already out of date on the pellet supply problem that we've got in Southeast Alaska. It is huge. You know, pellets really make sense for large urban areas because they're easy to operate. They operate similarly to a fossil fuel system. You know, you just have a great big silo instead of a fuel tank. You fill it up, it automatically feeds, and you just have to periodically remove the ash and make sure that there's no jams in the auger. And generally, they tend to run by themselves. They are also super clean burning. So for example, the SEALASKA building that we've been talking about is in downtown Juneau. In Alaska, we have 2 cities that are non-attainment areas by the EPA, Fairbanks and Juneau, for the same reason, air inversions and being a little pocket. But that downtown Juneau pellet boiler has not added at all any particulate matter to the Juneau air quality. So in areas that are urban, they are really, they make a lot of sense. Also in places like Ketchikan Airport, which has got a similar boiler installed there, they didn't have a very large footprint. They couldn't really afford to put in a great big huge chip boiler like the one in Galena, and there really was no point in putting in a cordwood boiler, so they put in an automated pellet boiler. We have in Ketchikan 5 boilers that are not burning pellets right now because of a pellet supply problem. And we really would like to resolve this. We have a timber industry in Southeast Alaska, and we have a wood waste available that could become pellets. But building and installing a pellet mill is expensive. We had a small pellet manufacturer in Ketchikan that was making pellets, but the owner of that business developed an allergy to the cedar dust and had to stop making pellets.
Carl.
Karen, do you find
Yeah,
any,
it is.
do you find any
I'm sorry?
of the do you find any of the operations burning other items other than natural wood, such as used pallets or hard cardboard, or is it just strictly harvested wood?
We really require that our operators operate their boilers in compliance with the manufacturer's direction. And so that bars them from burning things that are contrary to being put in the boiler. The problem with pallets is it has nails in it. So I have seen people take pallets and deconstruct them and pull the nails out, but that's laborious and doesn't tend to work well. There are pallet burners out there. You do have to continually remove those nails out of the bottom of your burn chamber, though. I know that the cordwood boilers that we were talking about, those big round boilers, they will use cardboard to start combustion, but they're not burning a lot of cardboard in there, and it does not make sense to just burn cardboard in those boilers, and that is contrary to the operations for those boilers anyway. We are looking at a cardboard boiler that might work in Alaska, but right now, and I was talking with Michelle about this earlier, we have yet to find any place that collects a significant volume of cardboard that would make sense to operate a boiler like this.
With Bernie Carl?
Well, yeah, and the problem with cardboard is the making of the cardboard puts chlorine into the paper, and so the emissions are a little bit more challenging if you burn cardboard.
Further questions?
And we have a white paper on that too that I can send on to Jomo.
Okay. Looks like we're pretty quiet here in the room. Is there anyone else online who has a question?
Tiffany, any thoughts? Did I miss anything?
I
You did
personally
an
thought it was
absolutely fantastic
quite
job.
all right. Well, Ms. Petersen, thank you so much. Again, when I was talking to Ms. Michelle about this presentation, it certainly made me interested, and it's quite interesting stuff. So thank you very much. I'll circle around with you. If anybody has any requests for information, I can forward those along to Karen for follow-up.
Yep. Yep,
Okay.
I've got a note, Jomo, I'm gonna send you the BTU Act information, the cardboard burning information, and the pellet supply situation information right away. I've got those on my laptop, and as soon as I'm done speaking today, I can go ahead and send those to you. And we'll work on getting a forward of that emission data that Daisy's collected too.
Outstanding. All right, Ms. Petersen, thank you so much.
All right.
All right.
I'm turning off the recording.
Okay, thank you very much.
Stopping share. Yes.
Okay.